and he's an industrial engineer by educational training, and over his 15-year career has been a project manager and management consultant for most of the major consulting firms, AT&T, Pricewaterhouse, Hitachi, really helping major manufacturers and high-tech companies deploy technology solutions. And I'm curious, Mario, as someone who's, an engineer and worked as a consultant with IT implementations, kind of what sort of inspired you to, what business need did you see out there that sort of inspired you to launch Predikto and start this business? Can you tell us a little bit about that?
Sure, yes. I come from the world of large ERP implementation, so primarily in the Oracle ERP implementation systems, the biggest ones being Oracle and SAP. So I was a consultant deploying these very complicated, expensive software solutions to Fortune 500 clients. And I was kind of frustrated with the lack of an ROI, true business value that was being added. A lot of customers were just continuing to spend a lot of money upgrading these complicated systems, and the value just wasn't really there over the years. And I was looking for something that was transformational, that would move the needle, that made an impact to the bottom line. And there was a natural gas pipeline company that had a failure that was $23 million in one day. And they went looking for a predictive analytics solution for Oracle EAM, which is the EAM module they were using. And Oracle had 20,000 partners globally, and nobody had predictive analytics for Oracle EAM, which I was very surprised with. So that kind of triggered this idea of saying, let's go out and build simple to deploy predictive analytics solutions for clients running Oracle EAM or any other EAM. So that was the birth of why we decided to start the journey with Predikto.
Great. Well, thanks for sharing that. And all right, well, before I turn things over to Mario, a few quick housekeeping items. I do have, for our listeners out there, your phone's on mute. Just because we are recording today's session, we'll share the link to the recording after the presentation. Mario has also agreed to share a PDF of the slides today, and there'll be a brief survey at the end, and just let us know if you'd like to receive a copy of today's presentation. But Mario has also agreed at the end of his formal presentation, which is about 35 minutes or so, he will stay around through the hour to answer any additional questions. So please feel free to type your questions in at any time during today's session in the questions feature in GoToWebinar, and I'll be happy to ask them of Mario at the end of the session. We'll also have a few polls during this presentation, so please get ready to make your responses. So without further ado, I'll turn things over to you, Mario.
Perfect. Thank you, Rona, and I hope you can see my screen. And you did ask me one thing to do, which was to remind you to record. So I think that's the one action item you asked me to help you with, Rona. So,
yes, the recording is taking place. Thank you.
Okay, great. So again, thank you for joining this webinar. We'll go through a very brief background. I think Rona did a pretty good job. I am a University of Florida industrial engineer, so I live in Atlanta now. So there is quite a big rivalry here in Georgia with the big SEC. But got my MBA at Georgia State University. Like I said, I come from an Oracle ERP implementation background with an energy and utilities, manufacturing, and telecom industries primarily. And we founded Predikto back in 2012. Based out of Atlanta with some team members now spread throughout different cities within North America. For the webinar today, we're going to be talking about just basic business challenges related to predictive analytics, some overall background on predictive analytics. We'll get into some use cases, how to get started, and then just deployment options. If you want to move forward with predictive analytics, what are ways that you can start and begin to see some simple opportunities, and obviously we'll leave some time for Q&A at the end. and Rona was nice enough to invite me last year, and we had a very active Q&A session towards the end of the webinar. So hopefully we'll get a lot of questions and be able to answer them today. So with that, Rona, the first poll question is up. If you want to flash that on everybody's screen.
Sure. So we just want to get a feel for who's on the line with us today. So if you don't mind just letting us know your job functions. Are you someone in the maintenance department, maybe in planning, scheduling, perhaps in engineering, operations, or some other department? So just to give us a feel for who are our listeners today and letting Mario know. And again, these polls will be anonymous. So just let us know your response. All right, it looks like we have about 3/4 of the votes in. Give it a few more seconds. Okay. Let me go ahead and share the responses. So it looks like almost half the people, 48%, Mario, are part of the maintenance team, 16% in planning and scheduling, 13% each in engineering and operations, and about 10% are in a different department. Okay?
Okay.
Back to you.
Great. Thank you. So this is a picture of Marty Cooper. Marty Cooper was the guy from Motorola who invented the modern cell phone. And I don't know if you guys on the phone remember the 2.5-pound clunkers that we used to haul around. Very, very heavy old technology. I show you this picture because we believe predictive analytics is at this stage, maybe a little bit past this stage, because we are seeing some use cases and some deployments in different industries having some big impacts. But predictive analytics has not reached the flip phone stage yet. It is very early. The opportunities are huge and massive. I'll talk to you a little bit about some use cases and some examples and what's going on in the industry and how perhaps you can get started as well. But yeah, just wanted to convey this interesting story of Marty Cooper. And the first phone call that he made was to his competitor, saying, I just cracked it. I just invented it. Here it is. So that was interesting. The next slide, you've seen this a million different ways. It's a lot of people talk about the big data and technology that's being invented and used and deployed in order to maximize big data. The essence of the slide here is that there is so much data being generated today within your plants, within your operations, from either sensors on your equipment or how you're capturing human, OEM, purchasing, specs, maintenance, preventative, reactive, whatever it is, about the way you run your plants, your operations. And in reality, so little of that data is actually being used. And what I'm going to talk to you about today is how predictive analytics can help tap into some more of the data that you already have in order to improve operations and hopefully reduce reactive maintenance, reduce downtimes, and just be a little bit more efficient and smarter about how you're running your plant. Operational information is completely segregated and siloed at the different organizations that we've had the pleasure of working with. Data from sensors is sometimes going to obscure databases. Some clients are using Pi software, OSI soft. But that information, that rich information, the heartbeat of the equipment, if your equipment has sensors, is completely siloed from your EAM or CMMS system or whatever other ERP systems you might be using. And if you incorporate financials data, environmental, weather data, maybe the human side, who is the operator, what kind of training does this maintenance person have, and a slew of other pieces of information, all of that is usually siloed. And this siloed data is one of the bigger challenges as to why companies are struggling to leverage the information that they already have and use it in better ways. And the biggest challenge that we find is not so much in the technology, because there's a lot of technology out there, and there's a lot of companies selling you technology. We believe that the biggest challenge is being able to provide something that's simple and actionable. So when you're talking about anybody within your organization about an IT project or an IT solution or using technology in any way, I would encourage you guys to say, well, what does this mean to me, to my world? What action am I going to take, right? Because a lot of times companies spend so much time and money on the enabling technology that has faster database processing, or more sensors and more alarms and more software. And in the end, you ask yourself, well, what action am I going to take, and how does this action impact my bottom line? So that's something critical that we strongly recommend anybody that's working on any process improvement or technology initiative to ask the question, how am I going to perform an action? And is that simple enough for me? So that's critical. So before we keep going, Rona, we have the second poll question, if we can learn a little bit more about the audience that we have here today.
Sure. So again, we just want to invite our listeners and just give us a feel for who's on the line with us. I think what Mario's going to be talking about will really span any industry, but it's kind of good to know if you're in, sorry, we only had 5 choices, so we had to take some educated guesses. We may or may not be correct, but let us know if you're in the manufacturing space, perhaps oil, gas, energy, and utilities. Are you in any food and beverage processing, chemical processing, or perhaps some other industry? All right, so I'll just leave this open, like we're about 80% in. Give you a little more chance to respond. Okay. Mario, so it looks like about 42% are in manufacturing. 42% are also in other. I wish we had more than 5 choices to learn what those others are. And then the remaining 6% oil, gas, energy, 6% in food, 3% in chemical processing. Okay?
Okay.
Back to you.
Great. So predictive maintenance today is widely used. I mean, the improvements in uptime have been significant as companies have been rolling out vibration analysis, infrared oil analysis, and other predictive maintenance techniques and tools. Some of the challenges with the current predictive maintenance processes is that they're highly manual. You need to send somebody out to use these tools to capture the data in handheld devices or whatever other methods that you're using. And the accuracy varies quite a bit. And depending on how accurate and what kind of time frame you can give on a delay, it depends on who's capturing the information, who's analyzing the information, and how that analysis is being provided to whoever is responsible for maintenance to be able to act. Some of the things that we're hearing from maintenance folks is, look, we have a lot of these techniques and around predictive maintenance, but there's just so much output, there's so much information, and I just don't have time to go through all of this paperwork and all of this output. I need to know where I need to be in the next, 10 days, 5 days, 3 hours, or 30 days in order to prevent an unexpected downtime. So predictive analytics is just another tool within your toolkit in order to help you sift through all of this data, not just the sensor data from the equipment and the historical maintenance, but also any predictive maintenance information that is generated from the different tools and processes and techniques that you guys are already using today. And predictive maintenance, it is a very large industry. It's about a $9 billion industry globally across all domains and all verticals. So the next slide is beginning to talk about predictive analytics. Predictive analytics is the leveraging of all of the information that you could have. Maybe you start with only 2 pieces of information, sensor and data and maintenance history. It doesn't have to be all. And using that data and creating statistical, machine learning, or algorithms or models. There's many different terms that are used, but in other words, is using complex mathematics in order to take that data and predict what's going to happen in the future, right? Predicting that your car is going to break down in the future and by leveraging whatever gauges and sensor information might be generated, right? The accuracy of these predictive models varies quite a bit. In our experience, we're working above 90% on overall accuracy, but that accuracy is always dependent on the quality of the data as well. You'd be surprised, a lot of clients say, well, our data is just not that good and it's not that clean. Nobody's data is. But you know, if you don't have any data whatsoever, then obviously there is no no possible way the statistics is going to be able to help, right? We need some historical data in order to predict the future, and predictive analytics is about simplifying that future prediction. It leverages existing data that's already there. Some vendors, want to install additional sensors and things like that. In our experience, we're finding that clients have already been capturing, significant data to be able to get started. And once this is, installed, it is less expensive and less resource intensive, and it runs in the background. It's kind of automated. So that is making people's lives a little bit easier in managing their operations. And it's important for whatever predictive analytics solution that you guys consider deploying, that it is easily integrated into existing processes. You guys have been doing projects for years, trying to constantly move the needle. It could be an RCM initiative or other initiatives within your plant. Predictive analytics is not about starting from scratch or starting a huge initiative. It's about taking data that you already have and finding an easy way of integrating into your current predictive maintenance processes, right? Predictive analytics, depends on how it's deployed. Think of it as a black box, right? Data is being generated on the left-hand side from all kinds of different sources and systems and ERPs and maybe sensors. That data is flowing in, it's being consolidated, transformed. ETL stands for extract, transform, and load. And predictive models are used to analyze that data. And the output that is generated, we like to keep that output as simple as possible. So when you're talking to a vendor, think about that actionable component, right? How am I going to use this data? So if the easiest way to use the output of predictive analytics is a simple text message or a CSV file that gets imported into your own EAM or emails, for example, or could it be an email notification? It doesn't matter. The key, that the conversation that you need to have is what kind of actionable output am I going to get that our plant can easily use? And that is key. So think of predictive analytics as a black box. It's obviously highly technology-based, but think of that process change on your end and your end users and how they're going to be able to easily leverage the power of predictive analytics. A lot of clients ask, well, what do you mean by predictions, right? What can you predict? How does that work? And, predictive analytics is the ability to analyze and interrelate any available historical and real-time data in order to predict the future, a future condition, a future event, something that you care about that can trigger an action that's going to save, a piece of equipment from breaking down. That prediction could be presented in many different ways. For some people, it could be as simple as, hey, you have this many hours until something fails, or this many days. For others, it could be a probability. We are now saying that there is a 10% chance that something's going to fail in the next 7 days, or a 90% chance that something's going to fail within the next 7 days. And those predictions could be given hourly, daily, weekly. It doesn't matter. What matters is incorporating that into a process and into a way that's actionable, that makes sense. If I tell you that the locomotive is going to fail in the next 5 minutes, that doesn't do anything for anybody, right? But if I can say that the locomotive is going to fail in the next 5 days, that gives the railroad company plenty of time to be able to plan their maintenance, make sure they have the right parts in the right shop wherever it makes sense for that locomotive to be able to go in for a deeper dive inspection, right? For some clients, predictive analytics is also being able to be used to predict production yield. So how much scrap am I going to have on this future batch based on these settings? And we're finding that in the chemicals industries, continuous process like steel manufacturing, the production yield prediction is something sometimes they're even more interested in than just predicting when a piece of equipment is going to fail, right? And the predictions, just to clarify, doesn't have to be a prediction that the asset is going to fail, because many clients don't have too many, complete catastrophic failures, right? You guys are already doing a lot of predictive maintenance and other maintenance techniques in order to prevent catastrophic failures. But maybe the event that you want to predict is something that may lead up to a catastrophic failure, right? So when you think about predictive analytics, think about the event that you want to predict that you can perform an action on. And that event may or may not be a full-fledged, failure. This is another slide that just talks about, from data to action. I'm going to use the word action in today's webinar probably 25 times. And that's, if there's one word that I want you to walk away with is what action can you take? Right? So predictive analytics is critical by starting and understanding the business problem, the business and operational problem that you want to address. Is it a big enough problem? And then we evaluate, well, what kind of data do you have that is related to that operational or business problem? And then you start working on the predictive analytics models and what you can predict, and then you present those predictions to the team, and you say, look, I can help you by predicting this event with this time frame. Is this something that is actionable to you or not? And if it is not actionable, it doesn't matter how accurate the model is. If you have an algorithm that can predict with 99% accuracy that, like I said before, that the railroad locomotive is going to fail in the next 5 minutes, that to me is useless because it is not actionable. So that key part of the conversation is important. So now I'm going to tell you a few use cases, one in steel and one in rail, which are areas where our company has a few clients in. And then we'll get into the final stages of the webinar as to what you guys can do to get started. So this is a very large, the largest steel manufacturing company in the world. They have been trying to predict failures in their plant equipment. The top diagram is a very, very simple drawing or diagram of this steel plant in Germany. Steel leaves a very hot furnace on the left-hand side, and it flows through a lot of rollers and stands, and the diameter of the steel gets squeezed and squeezed and squeezed until you have at the end these long steel rods, right? These guys wanted to get from 725,000 tons to 800,000 tons of steel produced in this one plant, and they couldn't because they had too many delays, about $22 million worth of delays. And in this case, we were evaluating data from about 200 different assets. And, predictive analytics is helping them because we're able to receive that data, process that data, and give them a warning. For them, it's only a 3-hour warning, which is very valuable to them, that says, look, you're going to have a failure of this type of failure, in this part of the plant within the next 3 hours. And they're able to deploy resources to go investigate the particular stand or the particular area within the plant to be able to identify, what the problem was, right? These are very high accuracy algorithms. We're able to paint a pretty simple picture. And for them, they said, look, we don't necessarily want all these really great-looking dashboards. We just want an email that says we're going to have a failure, and they can stop the process and deploy somebody to perform a deeper dive. Another example is hot boxes. Hot boxes are these little yellow boxes. They cost about $250,000 each. There's about 6,000 deployed in North America. And their job is to measure the wheel bearing temperature on a railroad car. So whenever a railroad car goes over these hot boxes detectors, if that wheel bearing is very hot, an alarm goes out to the conductor, and the conductor stops the train, gets out, and visually inspects and tries to identify if there's actually something wrong with the wheel bearing. Historically, trains used to derail a lot. And the number one reason in the past used to be when these wheel bearings would get really hot, and they would explode, and the wheel would come off, and the train would derail, creating a lot of problems. So the industry is significantly more safe today because of these installations of these hot box detectors. But what it's caused is trains are now stopping unnecessarily when these little boxes fail, right? So now there's may not be anything wrong with the train, but the hot box as the asset is now failing and unnecessarily impacting operations and the speed by which the train can get to its final destination. In this case, the railroad company said, we would like for you to give us a prediction that these hot boxes are going to stop a train unnecessarily, or the hot box is going to fail. And we want a 7-day time period, right? So for them, 7 days was enough to be able to deploy a maintenance technician to go calibrate or perform some maintenance on the HBD, the hot box detector, and track if we're being successful and we're moving the needle or not. Right? We're expecting to see by the end of this year about a 30% less train delays from the actual HBDs. So this is a way that predictive analytics is being deployed within the railroad industry. So with that, Rona, we've got a third, and I believe this is our last poll question. If we can activate this poll.
Sure. So for our last question today, Mario is asking you to describe your current predictive maintenance program. Where are you in this space? Either perhaps there's no PDM program in place, and that's why you wanted to learn more about the analytics. Maybe you're considering or planning to implement PDM. You have preventive maintenance and are looking to take the next step. Or perhaps you've implemented some PDM, maybe some oil analysis, vibration analysis, infrared. Or you're considering implementing predictive analytics. Or perhaps you've already started down the path of implementing predictive analytics. So again, if we can just ask our listeners today, just let us know, where are you regarding your predictive maintenance program? All right, looks like we've got 3/4 in. I'll leave it open, let a few more people vote. Okay, I'm going to share the results, Mario. And currently, I guess we have the rule of thirds here. 31% have no PDM program in place. 31%, nearly a third, are considering or planning to implement a PDM program. 33% have implemented some form of PDM program. And 3% each are considering or have started to implement predictive analytics.
Well, that's great.
Back to you.
Perfect. Excellent. Thank you. So how to prepare, which is the bulk, I think 94% of our audience has not started or is considering. So complete and accurate prioritization of your asset list is important. A lot of these things you may already have or you're in the process of doing, right, as you're constantly trying to improve your maintenance processes within your plant. You need to identify the most appropriate maintenance strategy for each asset, right? For some, it just might make sense to run to failure. For others, just traditional preventative maintenance or predictive maintenance might make sense. And for some critical pieces of equipment where you may already have a lot of data that's available from the equipment, then predictive analytics would be the most appropriate. But the important thing is to strike the right balance between risk avoidance and cost, right? You don't want to be spending too much time and money and energy on predicting a redundant pump that just doesn't make sense to do so, right? For critical assets where predictive analytics does make sense, you want to start to begin to evaluate the current and potential information that you have that's generated from sensors. We do run into some clients that installed a lot of sensors, 5 years or so, and they did not have the human capacity to be able to manage the information overflow, and they started shutting some of those down, right? So now that predictive analytics is starting to get deployed, that rich sensor data is only helpful. So a lot of clients are kind of turning those back on as they're preparing to do some predictive analytics capabilities later on. It's important to make sure that the data that's being captured related to their processes is consistent, right? So if you're documenting downtimes or delays, even maybe a root cause, just trying to be consistent as to how you're documenting that helps. If it's a bunch of free-form text in Excel spreadsheets, it just makes it a little bit more challenging than if you have drop-down lists to be able to classify events or downtimes that you are interested in predicting later on. It's just easier if it's standardized, right? Leveraging existing functionality from your current CMMS or EAM systems as much as possible makes the most sense. eMate has quite a few modules and functionality within their software that would enable you to begin to capture more and more information. And the next slide will cover that a little bit. And then the change management side is critical. Too many IT or technology initiatives are pushed out and deployed without taking too much seriousness or too much effort into the change management. How is my job going to be impacted, right? People, it is a natural tendency to be intimidated by change, by new technology. Some people embrace it, but for the most part, we're very apprehensive towards embracing that. So it's important to work with the human side of your team members that are going to be impacted by giving them an explanation as to why am I having to capture this new piece of data, or why are we installing these sensors? What's the bottom line? What's the end picture? So guiding people through the purpose and the reason of the change is very helpful, and it increases the success rate of any technology solution that you're going to be implementing, technology or process-oriented solution. So a lot of people ask, well, is this thing real? Is this a crystal ball? I don't believe that predictive analytics can work. We love those questions, and we love showing our clients and our maintenance guys how it actually does work. So the next slide, we just wanted to show you a little bit about the eMate Condition Monitoring Center. They have the capability to be able to monitor different classes per assets. You can enter your noise, vibration, temperature, lubricants wear, other kinds of information that could be captured through independent devices. You can actually store that information within eMate, and then you can either file import the information automatically or enter the data manually. There are thresholds as well that eMate allows you to do to be able to trigger work orders or tickets or alarms. And obviously they have the to leverage the power of this module within eMate that is able to trigger automatic email alerts and work orders. So the more information that you have, the more organized that information is, the more powerful the predictive analytics solution that you can deploy with any vendor or any way that you want to leverage predictive analytics. So leverage that functionality from eMate if it makes sense for your organization. And then from a how to get started perspective, there are different predictive analytics companies that can help you analyze if you have the right level of data that's being generated from sensors. Are you capturing your maintenance history in a way that allows for predictive analytics to be easily deployed? The next step is to develop statistical models that are specific to your assets, to your processes. Companies have pre-built predictive analytics models for pumps, for motors, for compressors, for whatever type of asset class that you want. The development of brand new predictive analytics models that are specific to your assets can also be done very, very fast. So work with a company who is an expert in this area in order to be successful. You also want to validate the results. So once somebody comes back to you and says, hey, we can predict that this pump's going to fail, and we are 90% accurate in the prediction, you shouldn't believe anybody. And we encourage our own clients to not believe us. So that we have to prove to them, we have to validate to them that the results actually work. And that is either a 1 to 2 week process, or it could be a 3-month process. It just depends on the organization and the prediction accuracy. And then for us, predictive analytics is only useful. It's actionable, plain English, and anybody can use it, right? Anybody understands what is being suggested or predicted from the output. And importantly is to integrate these predictive analytics solutions within your business processes. And the last piece is start small. Don't try to boil the ocean. It is very new. You have companies like GE and IBM and other big players going after this. They have very limited solutions in some key asset classes. So don't try to boil the ocean. Pick 1 or 2 areas where there is a big potential, if predictive analytics is very successful, to move your needle from an operational efficiency or overall maintenance and reliability. So yeah, strongly suggest to start small. So how can you get started? What are options for you out there? Obviously, you can hire the contractors or the people and try to do it yourself. A lot of companies are starting to hire data scientists and statisticians and purchasing the necessary software, SAS or IBM, SPSS, or R is another statistical software that's free and open source. And obviously, you need the ETL tools to transform the data, to modify the data, to join that data. A lot of organizations, a lot of our clients have very large IT departments that can tackle this. The challenge is the statistics piece. So make sure you work with somebody who can prove to you that they have created predictive analytics models in asset-intensive pieces of equipment. Most of the data scientists and statisticians out there are really good at predicting human behavior or the stock market or marketing trends, if you're going to buy this sweater at this price range or not. In the asset-intensive space, very few companies can actually show you actual use cases that they have done. So definitely, work with somebody that can help you on the statistical side. You can also purchase enterprise-wide software licenses. IBM PMQ, it's a predictive maintenance and quality, is one of the larger, broader, well-respected, overall industrial Internet of Things predictive platforms out there. We are an IBM PMQ partner as well, so we are actively helping clients that don't want to go out with a cloud solution and want to go with a on-premise solution to go the IBM route. So IBM is certainly one of the leaders in that space. And a lot of the OEM vendors themselves, the guys who are selling you the gas turbine, if it's GE, they are now offering predictive analytics solutions with some of their pieces of equipment. But that's pretty new. So, many clients just want to deploy predictive analytics across other pieces of equipment where their OEM, seller does not offer it. So, and then you also have the ability to purchase predictive analytics on the cloud or software as a service from niche players. There's a few companies out there, Clockwork and MTEL, have predictive analytics solutions on the cloud, like we do at Predikto as well. So those are just some of the options that you can do. We strongly recommend you to start with a pilot. Don't go out and purchase a bunch of software and a bunch of large consulting engagements when you don't know what can be done for your specific plant or area. So start small, start with a proof of concept or a pilot, evaluate the problem, identify what data you have, develop the predictive analytics solutions, and validate the results that they actually work. And then work with your partner, your business partner, or whoever you're hiring to develop a business case and the necessary KPIs in order to make sure you're all aligned and moving to the next phase. A pilot could be as short as 2 to 3 weeks. We usually run our pilots around 2 to 3 months. We're finding that that's a good time period because our clients just sometimes take a while to send us the right data and to get to that actionability part of the output. So with that, Rona, that's the end of the presentation. We've gone for about 40 minutes. I would like to open it up for some Q&A, and hopefully we'll have a pretty good discussion.
Great. All right. Thanks, Mario. And again, we've had a few questions come in during Mario's presentation, but please feel free to use the questions feature and type your questions in, and we'll get to as many as we can and ask them of Mario. And Mario, earlier I think you mentioned about a 40% accuracy rate for predictive maintenance. Can you drill into that a little more and explain how that number was derived at?
Yeah, so that number actually came from an IBM paper that was written as it related to the overall predictive maintenance industry. Some of the challenges is there's a lot of rich data that could be generated from vibration analysis, for example. But how that vibration analysis is, vibration data is analyzed and how it turns into an action recommendation, sometimes the accuracy is not as high, right? So accuracy depends heavily on a time period as well. So if you're saying that something's going to fail in the next 3 hours or in the next 3 months, you know, measuring that accuracy within a time period and sticking to that accuracy within that time period and saying, yes, we nailed it, we were correct within this time period, is just pretty tough, right? Depending on the different solutions that you use. So that's you know, that came from a white paper that we had read, and we wanted to throw that in there. But it varies significantly depending on the tool that you use, the industry, and who's actually analyzing the output as well.
Gotcha. And does it also vary by the different types of, like you mentioned, there's, you know, different technologies, there's vibration, infrared, right? Do you find that you can apply this tool more accurately with different technologies?
Yes, the more data that we have, if we have sensor data coming from the pieces of equipment, we have maintenance history data as to when preventative or reactive maintenance was done, and we combined, we add to the models anything around vibration or infrared. It is just more data that tells us how this piece of equipment is changing over time, right? Is it starting to vibrate more? Is it starting to generate more heat? What's happening? And by having more of that historical data and understanding how that pump behaves and how long you have until a complete failure occurs, the more data that you have from these other predictive maintenance techniques, the more accurate the models can be.
Great, and that does beg the question then, Mario, how much data, you know, for how long a period do you need to collect before you can really start to have your models be predictive?
Yeah, that's a great question. The time frame of data depends on the number of events in the data set. And what we mean by that, if you want us to predict when this pump is going to fail, then we need enough data for about 20 or so events within the data set. That could be 6 months, that can be 6 years, right? But we need a data set of at least 20 events. That's why some clients say, well, I don't have that many catastrophic full failures, so I don't have too much, 20 data points within my data set, but let's go ahead and pick the prediction event to be something else. Maybe when, a specific threshold is hit within temperature or vibration or something, and we've hit that more often in the past, and that will be the event that we want to predict. So enough data to have about 20 events in the data set is what is ideal in order to develop a predictive analytics solution.
Okay, great. That's good to know. And you mentioned that about it's also important is the things you need to do in preparation is to have the right strategy for each asset. Can you just elaborate a little bit on how when you are prioritizing your assets in your experience, Mario, give a couple of examples of how you would do that prioritization?
Yeah, so a lot of our clients, obviously they all know their equipment much more than what we could add, right? We are not experts at telling a pulp and paper plant how they should identify the criticality of their assets and what kind of maintenance they should do. There's a lot of people that are experts in that. We are kind of algorithm predictive analytics experts. So what we're suggesting to clients is to say, once you understand which one of your assets are critical, and you've identified the right level of maintenance for those critical and maybe not so critical assets, then we say, well, let's start with the big ticket items, where if you do have a downtime, it has a significant impact to your operations, right? An asset that if it's down and you have other redundant assets and it's not going to cost you $1 million an hour, then you probably don't have that many eyeballs and that many predictive maintenance tools and processes on those not so critical assets. But on the critical ones, yes, you already have a lot of data. You probably already have a lot of eyeballs on that. And leveraging the power of predictive analytics on those critical assets would be the place to start.
Great. Okay. That's helpful. One question came in and asked is PdA really similar to SPC? I assume that means statistical process control, but focusing on equipment rather than on product. Can you, kind of explain how predictive analytics relates, or maybe doesn't relate, or is similar to or not similar to statistical process controls?
So predictive analytics is a very broad term, and predictive analytics is used to predict stock prices, to predict if a patient's going to get sick or not, or die based on conditions. It's used in marketing. It's used in a lot of different areas. So predictive analytics is just a broad umbrella that is all about bringing in data and leveraging statistical methods, a slew of different methods, in order to predict an event, right? Weighball is something that's, used quite a bit within the maintenance, organizations and maintenance areas, but it's just one tiny little piece of the equation, pretty rudimentary compared to some of the more advanced statistical methods. So anytime you're using advanced mathematics and data to predict an event, that's all predictive analytics, and it could be across any industry.
Gotcha. Okay, thanks for clarifying that. We had one listener ask, in the case where they're currently in a run-to-failure mode, they're still in the early stage, how can you help justify the cost in predictive analytics, or predictive analysis, and taking that first step? Are there some, if you want to sort of inspire the financial people to have an incentive to move in this direction, are there some thoughts on that,
yeah,
and how you might go about doing that?
So predictive analytics solutions can vary quite a bit from a cost perspective. If you go with a cloud-based application, it's actually pretty inexpensive to run a pilot, right? Where a team can take your data, analyze that data, and perform the predictive analytics models and show an ROI, and says, look, based on what this would cost you on a monthly basis, if you experience at least 10 or 20 failures a month, and those failures cost you, X number of $1,000s a year, then you would be surprised at how easily you can justify an ROI for anybody running right now their plant or some pieces of equipment on a run-to-failure mode. It's not that expensive. I mean, for us, starting price is $10,000 a month, right? If you go with a industry-wide, corporate-driven IT solution like IBM PMQ, it depends on the number of assets that you're going to be monitoring and the implementation. It could be as cheap as $600,000 to get started, and not that that's cheap, but depending on if you're a $10 billion organization, that is not a significant investment in software, and that can get you started in predicting assets in a particular asset class for one or all of your plants, depending on how you do the licensing agreement with IBM. So the cost of getting started could be very low or it could be high depending on how you want to approach it. So don't be intimidated by thinking predictive analytics is some unreachable, incredibly expensive, high-tech solution, right? There are different options for different companies depending on the appetite and the approach that they want to take.
Gotcha. So it sounds like a really good starting point would be to just even start to estimate what the cost of an outage or downtime is.
Exactly.
And just probably collecting that data helps you start to build the case. And then when you can project each time this occurs, if it saves one occurrence, I've saved this much. Good. Okay.
Yeah.
Very good. Someone was asking, about getting data into eMaint regarding our condition monitoring and proactive. So since we have listeners here with all different CMMS systems, I'll be happy to follow up in more depth after from our services team. But in a nutshell, when data is entered either by importing or, as Mario indicated, you can either import the data or we can set up integrations to automate that process and pick it up periodically. But the whole idea is just defining what are acceptable levels or thresholds of the various different classes, and then we will automatically generate a corrective work order if things fall outside of that class. So that's kind of the theory, and we'll certainly have someone follow up after for the actual application. Let's see. So are there additional questions for Mario? Let me just look through there. Yes, there was one question. Is so many of our users are in the maintenance department, and in your experience, does this have to be jointly with IT and maintenance, or what's the most successful route for accessing this data and getting it in a format that could make this kind of endeavor successful?
Yeah, that's a great question. We are really on the side of operations and maintenance, right? So that's the world that we like to speak with, and we talk about, what is the pain, how much is reactive maintenance costing you today, and then we say, all right, let's start with a simple pilot, and we usually just ask for some CSV files, 6 months of data. Most of our clients can actually, their operations folks themselves can extract some data into Excel or CSV files and upload that to us. And that allows us to run a pilot and to show what can be done. Once we're getting ready and they say, wow, this is amazing, we don't believe you, but let's give it a validation, test period, let's try this out. At that time, yes, we would need IT to get involved, because then they would have to be sending us data once every 30 minutes, once a day, once a month, whatever that time period is. And at that time, IT gets involved. But it is heavily driven by operations and maintenance in the beginning and throughout the entire project. IT just comes in later on once we're ready to move into a production, live data feeds kind of environment.
And I think we have time for one more question, Mario, and that you alluded to the need to kind of, to be successful, you mentioned, you should have 20 events for really a model to be statistically accurate, but that also it was helpful to have your data standardized. Can you just, for our listeners out there, kind of drill down on that a little bit and define what you mean by standardized data, because that sounds like a key takeaway that would be easy to implement.
Yeah, and what we mean by that is if you're documenting a maintenance that was done on a piece of equipment, just standardize how you're documenting that maintenance. Was it reactive maintenance? Was it preventative maintenance? Because of the reactive maintenance, did you have a downtime? How long was the downtime? Do you even know where, to what level of detail you're documenting that downtime? And if you're documenting, a root cause, just be consistent on how you're documenting those root causes. So whatever you're documenting, we were just saying the more consistent and standardized it is, and the less it's free text form, the better. That's what we meant by that. If you have, a lot of Excel spreadsheets with a lot of free text form and spelling errors and all kinds of other information, it just gets a little bit more challenging.
Well, that's true, and I guess those are even good best practices even for just being able to run standard reports at CMMS or even to do human analysis. That's a good rule of thumb.
Yes.
Well, great. Well, we're just about out of time here, so again, I would like to thank Mario and Predikto for kind of starting this conversation, and I'd like to encourage our listeners today. I'd like to thank you all for joining us as well, and encourage you to continue the dialogue with Mario. It sounds like it is a journey, just like a CMMS is, and all the things he spoke about today, just getting started, will help you get closer to ultimately being able to implement something like this and find value in it. So again, thanks to our listeners, thanks to Mario. There will be a brief survey at the conclusion of the webinar, and please indicate there if you'd like to get a copy, a PDF of the presentation, and Mario will follow up and send that to you. I also did record today's presentation, and we'll email a link to all of our listeners today in case you'd like to share this with others. And also, please just give us a little bit of feedback on other topics you'd like for eMaint or Mario and his team to present. We want to make sure that we're bringing information to you that really is actionable, as Mario says, and helps answer some of the questions or solve some of the business challenges you're having. So. Again, this is Rona from eMaint and Mario from Predikto, and thanks, Mario, for putting this together, and thanks for our listeners for joining us. We'll see you all.
Thank you for the opportunity. Thank you, Rona, and thanks everyone for joining.
Take care.
Bye-bye.